Class diagrams, an advanced concept. Introduction. We will discuss the following topics in this chapter: perspectives, associations, attributes, operations, generalization, constraint rules, when to use class diagrams, stereotypes, object diagram, class scope operations and attributes, multiple and dynamic classification, aggregation and composition, derived associations and attributes, interfaces and abstract classes, referenced objects and value objects, collections for multi-valued association ends, frozen, classification and generalization, qualified associations, association class, parameterized class and visibility. Perspectives. This class diagram describes the types of objects in the system and various kinds of static relationship which exist between them. There are two principal kinds of static relationship. Association. For example, a customer may rent a number of videos. Subtypes. A nurse is a kind of a person. There are three perspectives you can use in drawing class diagram. Conceptual. So drawing a diagram that represents a concept in the domain under study which will naturally relate to the classes that implement them, there is no direct mapping. This can be considered language independent. Specification. Here attention falls on the interfaces of the software, not the implementation. In spite of the emphasis of object-oriented development greatly on the difference between interface and implementation, the notion of class in an object-oriented language combines both interface and implementation. The key to effective object-oriented programming is to program to a class interface rather than to its implementation. Implementation. In this view, we have classes and we are laying the implementation bare. This is probably the perspective used most often, but in many ways, the specification perspective is often a better one to take. The UML can be used with all three perspectives. Mark classes with implementation class to show the implementation perspective and with type for the specification and conceptual perspectives. Association. Relationship between instances and classes are well represented by association. From the conceptual perspective, association represent conceptual relationship among classes. As each association has two association ends, each end is attached to one of the classes in the association. An end can be explicitly named with a label called role name. Unless there is label, name can be given at the end of the target class so. An association end also has multiplicity, which is an indication of how many objects may participate in the given relationship. The multiplicity indicates lower and upper bounds for the participating objects. The star represents the range 0 to infinity. The 1 stands for 1 up to 1. The most common multiplicities in practice are 1, star, and 0 to 1. Association represent responsibilities within the specification perspective. For updating the relationship, an association also implies some responsibility. These responsibilities do not imply data structure. Imply pointers in both directions between the related classes in an implementation model. We have arrows on the association lines which indicate navigability. Navigability is an important part of implementation and specification diagrams. If navigability exists in only one direction, we call the association a unidirectional association. A bidirectional association contains navigability in both directions. Bidirectional associations include an extra constraint, which is that the two navigations are inverses of each other. Although the instances connected may change over time, an association represents a permanent link between two objects, and the link continues to exist the whole lives of the objects. Attributes. Attributes are likely to be similar to association. A customer's name attribute indicates that customers have names at the conceptual level. Attribute indicates that a customer object can tell you its name and has a way of setting a name at the specification level. A customer has a field for its name at the implementation level. The UML syntax is visibility name type equal to default value, where visibility is the same as for the operations. Difference between an attribute and an association. From the conceptual perspective, no difference. At the specification and implementation levels, attributes imply navigability from the type to the attribute only. The type contains solely its own copy of the attribute object. That is, any type used as an attribute has value rather than reference semantics. Operations. Operations are the process that a class knows to carry out. They correspond to the methods on a class. At the specification level, operations correspond to public methods on a type. Private and protected operations are shown in the implementation model. The full UML syntax for operation is visibility name of parameter list return type expression open bracket property string bracket closed, where visibility is plus public comma hash protected comma or hyphen private. Name is a string. Parameter list contains comma separated parameters whose syntax is similar to that for attributes. Direction name type equal to default value. The only extra element is direction, which is used to show whether the parameter is used for input in, output out, or both in out. If there is no direction value, it's assumed to be in. Return type expression is a comma separated list of return values. Most people use only one return type, but multiple return types are allowed. Property string indicates property values that apply to the given operation. An example operation on account might be plus balance on bracket date money. Operations. Within conceptual models, don't use operations to specify the interface of a class. Use them to indicate the principal responsibilities of that class, using a couple of words summarizing a CRC responsibility. UML defines a query as an operation that gets a value from a class without changing the system state. Operations that do change state are modifiers. Queries can be executed in any order, but the sequence of modifiers is more important. A getting method returns a value from a field. A setting method puts a value into a field. An operation is something that is invoked on an object. A method is the body of procedure. UML uses the term feature to mean either an attribute or an operation. Generalization. In a specification model, the interface of the subtype must include all elements from the interface of the supertype. It is called as generalization. The subtype's interface is said to conform to the supertype's interface. In implementation perspective, it is associated with inheritance in programming languages. The subclass inherits all the methods and fields of the superclass and may override inherited methods. Subclassing is one of the ways to implement subtyping. You can also implement subtyping through delegation. With either of these forms of generalization, you should always ensure that the conceptual generalization also applies. The subtype implements operations in a different way. You may choose not to show the subtype on a specification perspective diagram if there are cases in which a subtype has the same interface as its supertype. Constraint rules. Activities in drawing a class diagram indicate constraints. So the basic constructs of association, attribute, and generalization do much to specify important constraints. They cannot indicate every constraint. The class diagram is a good place for capturing constraints. Anything which can be allowed by the UML to describe constraints. The only rule is that you put them inside the braces. Rules should be implemented as assertions in a programming language. When to use class diagrams? Class diagrams are the backbone of almost all object-oriented methods. Tips to use class diagram. To all the notations available to you, don't try to use all. Start with the simple stuff in this chapter: classes, associations, attributes, generalization, and constraints. From the perspectives, your drawing fit the models to the stage of the project. If you are in analysis, draw conceptual model. While working with software, concentrate on specification models. When you are illustrating a particular implementation technique, draw implementation models only. Instead of drawing models for everything, concentrate on the key areas. Because it is better to concentrate on a few diagrams that you use and keep up to date rather than to have many forgotten and obsolete models. Focus on the conceptual and specification perspectives to avoid getting bogged down in implementation details too early. Stereotypes. Stereotypes are the core extension mechanism of the UML. Even though you need a modeling construct which is not in the UML, it is similar to something that you treat your construct as a stereotype of the UML construct. Example, if a class has only public operations excluding method bodies or attributes is termed as a UML interface. This corresponds to interfaces in Java, COM and Corba. Hence, interface is defined as a stereotype of class. Stereotypes are usually shown in text between geolements. For example, interface. Many extensions to the core UML can be described as a collection of stereotypes. Within class diagrams, these might be stereotypes of classes, associations, or generalizations. Stereotypes are subtypes of the meta model types class, association, and generalization. A profile takes a part of the UML and extends it with the stereotypes for a particular purpose. Object diagram. An object diagram is a snapshot of the objects in a system at a particular point of time. Since it shows instances rather than classes, it is also called an instance diagrams. Use an instance diagram to show an example configuration of objects. An object diagram is a collaboration diagram without messages. Use an instance diagram to show an example configuration of objects. Class diagram of party composition structure. Object diagram. Each name takes the form instance name, class name. Both parts of the name are optional. Object diagram showing example instances of party. Class scope operations and attributes. As UML has class scope, UML refers to an operation or an attribute that applies to a class rather than an instance. This is equivalent to static members in C++ or Java and to class variables and methods in Smalltalk. Class scope features are underlined on a class diagram. Multiple and dynamic classification. Classification refers to the relationship between an object and its type. Single classification refers to an object belongs to a single type which may inherit from supertypes. Multiple classification indicates that an object may be described by several types that are not necessarily connected by inheritance. Multiple classification is different from multiple inheritance. Multiple inheritance. A type may have many supertypes, but a single type must be defined for each object. Multiple classifications. allows multiple types for an object without defining a specific type for the purpose. Make it very obvious which combinations are legal in multiple classifications by labeling a generalization line with a discriminator. A useful constraint intends to mean that any instance of the superclass must be an instance of one of the subtypes of a group. Multiple and dynamic classification. Dynamic classification allows objects to change type within the subtyping structure, whereas static classification does not do what dynamic classification does. A separation is made between types and states with the help of static classification. Dynamic classification combines these notions. The diagram shows an example of using dynamic classification for a person's job, which of course can change. Aggregation and composition. Aggregation is the part of relationship. It's like a car has an engine and wheels as its components. UML offers a stronger variety of aggregation called composition. In composition, part object may belong to only whole. In spite of a class component of many other classes, any instance must be a component of only one owner. The class diagram may show multiple classes of potential owners, but any instance has only a single object as its owner. Example: the figure in next slide shows examples of these constructs. The composition to point indicate that any instance of point may be in either a polygon or a circle, but not both. An instance of style, however, may be shared by many polygons and circles. Furthermore, this implies that deleting a polygon would cause its associated points to be deleted, but not the associated style. Aggregation and composition. Aggregation is the part of relationship. It's like a car has an engine and wheels as its components. UML offers a stronger variety of aggregation called composition. In composition, part object may belong to only whole. In spite of a class component of many other classes, any instance must be a component of only one owner. The class diagram may show multiple classes of potential owners, but any instance has only a single object as its owner. Example: the figure in next slide shows examples of these constructs. The composition to point indicate that any instance of point may be in either a polygon or a circle, but not both. An instance of style, however, may be shared by many polygons and circles. Furthermore, this implies that deleting a polygon would cause its associated points to be deleted, but not the associated style. Derived association and attributes. Derived associations and derived attributes can be calculated from other association and attributes respectively on a class diagram. For example, if you know that person's date of birth and age attribute of a person can be derived. Derived features indicate a constraint between values but not a statement of what is calculated and what is stored. This figure shows a hierarchical structure of accounts drawn from a specification perspective. The model uses the composite pattern. Note: detailed accounts have the attachment with entry objects. The balance of an account is calculated as the sum of entry amounts. A summary account's entries are the entries of its components determined recursively. To illustrate how derived elements indicate constraints, we use a class name time period. If this is a specification diagram, although it suggests that start and end are stored and duration of it is calculated, a programmer can implement this class in any fashion that maintains that external behavior. Derived values are valuable for annotating fields on implementation diagrams. Those annotated fields are used as catch for performance reasons. Use derived markers to remind where these derivations exist and to confirm with the domain experts on conceptual diagrams. Derivation exists with the domain experts. Interfaces and abstract classes. An abstract class is a class that cannot be directly instantiated. It has one or more operations that are abstract. An abstract operation has no implementation. It is pure declaration so that clients can bind to the abstract class. The most common way to indicate an abstract class or operation in the UML is to italicize the name. You can also use the label abstract. All features of interface are abstract, hence an interface is a class that has no implementation. You mark an interface with the keyword interface. Classes have two kinds of relationship with interfaces, providing and requiring. A class provides an interface if it is substitutable for the interface. A class requires an interface if it needs an instance of that interface in order to work. This figure shows the relationship in action based on a few collection classes from Java. There is an order class that has a list of line items. Since there is a list, the order class is dependent on the list interface. The array list itself is a subclass of the abstract list class. Abstract list provides some but not all the implementation of the list behavior. Array list implements list and collection is shown by ball icons, often referred to as lollipop. The fact that order requires a list interface is shown by the socket icon. Any class is a combination of not only an interface but also an implementation. A problem with interaction diagrams don't provide a very good visualization for polymorphic behavior. Generally, it is considered as a serious issue. This figure shows a more compact notation of interfaces, reference objects and value objects. Reference objects are such things like customer. For finding out software object to designate a customer in the real world, identity is very important. Any object refers a customer object will do so through a reference or pointer. Changes to a customer are available to all users of the customer. If you have two references to a customer and wish to see whether they are the same, you usually compare their identities. Value objects are such things as date. You often have multiple value objects representing the same object in the real world. If you have two dates and wish to find out whether they are the same or not, you look at the values they represent. Value objects should be immutable. Collections for multi-valued association ends. A multi-value end is one whose multiplicity's upper bound is greater than 1. For instance, star. The usual convention is that multi-valued ends are thought of as sets. There is no ordering for the target objects and no object appears in the set more than once. These assumptions can be changed by attaching a constraint. The order constraint implies that there is an ordering to the target object, that is, the target objects form a list. Use the back constraint to indicate that target objects may appear more than once without ordering. Use the hierarchy constraint to indicate that the target objects form a hierarchy. Use the DAG constraint to indicate a directed acyclic graph. Frozen. Frozen is a constraint that is applicable to an attribute or an association end. Frozen indicates that the value of attribute or association end may not change during the lifetime of the source object. The initial value may be null. Frozen indicates that all association ends and attributes associated with that class are frozen in a class. Since read-only implies that a value cannot be changed directly but may change due to a change in some other value, frozen is not the same as read-only. Mark freezing using the frozen constraint. Mark read-only values with read-only. Classification and generalization. Consider the following phrases. Sheep is a border collie. Border collie is a dog. Dogs are animals. A border collie is a breed. Dog is a species. If you combine phrases 1 and 2, we get sheep is a dog. When 2 and 3 taken together yield border collies or animals, good. 1 and 4 gives us sheep is a breed. The combination of 2 and 5 is a border collie is a species, not good. Why can't we combine some of these phrases and not others? The reason is that some are classification and some are generalization. Generalization is transitive, classification is intransitive. We can combine a classification followed by a generalization but not vice versa. Qualified associations. A qualified association is the UML equivalent of a programming concept variously known as associative arrays, maps, and dictionaries. From a software perspective, this qualified association would imply an interface as class order, public order line, get line item of product a product, public void add line item of number amount comma product for product. All access to a given order line requires a product as an argument, suggesting an implementation of using a key and value data structure. Use a qualifier construct only to show constraints along the lines of single order line per product on order in conceptual modeling. In specification models, use it to show a key lookup interface. In implementation models, use it to show uses of a map, dictionary, associative array, or similar data structure. This figure shows a way of representing the association between the order and order line classes that uses a qualifier. Association class. Association classes allow you to add attributes, operations, and other features to associations. The association class adds an extra constraint in that there can be only one instance of the association class between any two participating objects. We can see from the diagram that a person may attend many meetings. We need to keep information about how awake that person was. We can do this by adding the attribute attentiveness to the association. Association class subtitles. Role should probably not be an association class. These diagrams have relatively the same form. However, we can imagine one company playing different roles in the same contract. But it's harder to imagine a person having multiple competencies in the same skill. In the UML, only the later case is legal. You can have only one competency for each combination of person and skill. Implement an association class as if it were a full class, but provide methods that get information to the classes linked by the association class. You can use a temporal keyword on the association. Parameterized class. Several languages, particularly C++, have the notion of parameterized class or template. It is useful for working with collections in a strongly typed language. You can define behavior for sets in general by defining a template class set. Class set T open bracket void insert T new element void remove T an element. Use the general definition to make set classes for more specific elements. Set employee employee set. The T in the diagram is a placeholder for the type parameter. A use of a parameterized class such as set employee is called a bound element. You can show a bound element in two ways. The first way mirrors the C++ syntax. The alternative notation reinforces the link to the template and allows you to rename the bound element. The bind stereotype is a stereotype on the refinement relationship. Using a bound element is not the same as subtyping. Parameterized classes allow you to use a derived typing. When you write the body of the template, you make invoke operations on the parameter. Later declaring a bound element, the compiler tries to ensure that the supplied parameter supports the operations required by the template. Visibility Visibility is simple in principle but has complex subtleties. A class has public private elements. Any class can use public elements. Private elements can be used only by the owning class. Within the UML, you can tag any attribute or operation with a visibility indicator. You can use any marker you like. Meaning of the marker is language dependent. The UML provides three abbreviations for visibility: plus for public, hyphen for private, and hash for protected. In C++, a public member is visible anywhere in the program and may be called by any object within the system. A private member may be used only by the class that defines it. Protected member may be used only by the class that defines it or a subclass of that class. In Smalltalk, all instance variables are private and all operations are public. Private in Smalltalk is similar to protected in C++. Though Java is similar to C++, it adds a new visibility level called package. A member with package visibility may be accessed only by instances of other classes within the same package. A protected member may be accessed by subclasses but also by any other class in the same package as the owning class. Java also allows classes to be marked public or package. Public members of a public class may be used by any class that imports a package to which the class belongs. When you are using visibility, use the rules of